and I will pass it to Keith to talk about our load pin configurator.
All right. Hi, everybody. I'm load pin configurator. It's a long document. We had a configurator up recently that wasn't as long. We've added a lot more information to the configurator. All of it's not necessary, but more information is better. Before we get into the configurator, I just want to reiterate what Jeff was saying. Why? Ask why. Somebody says, I want a load pin. Why? What are you trying to do? Oh, I want to measure force. Okay. Why do you want to measure force? What are you trying to achieve? What's the intent of this measurement? I want to dig in and understand the application. It can help drive us in the right direction for a product. So things like dimensions and all that is very important, but also, what are they trying to achieve? Is it, these aren't as accurate as other solutions. They're very compact though, and they fit into the design very well in most cases. And so, what is the customer really trying to do? And then, the pin itself has dimensions, and there's dimensions of the mating hardware that applies load. And then there's also dimensions around the pin. You might have limited room, say, for the head of the pin, or the cable may interfere with other pieces of the assembly. So the whole package of not only the pin, but the dimensions of the hardware that load the pin and the dimensions of all the sort of extraneous hardware that may be around the pin is important. And so we have a number of dimensions on the configurator. So this is the first page, basically, and it says fill in the blanks. And you notice L1 is the overall length. And then L5, you've got kind of the active section, and typically that section wants to be completely loaded with loading hardware, such as a blade or a clevis or something. And then same thing as the outer section, which is defined as L4 and L6. And L4 and L6 aren't always the same length as each other, but they would be if, everything were left blank. But customer can certainly specify differently. And then you have something called a keeper plate, which keeps it in place. You have the orientation of the cable exit. You have L7, which is how far the pin sticks out of the assembly. So we ask you, fill in as many of these details as possible. You may not care about some of them. The customer may not care. That's okay. They may not care about the diameter. They may be trying to fit the pin into an existing installation where there's already everything and they just need to make the pin fit. So in those cases, extremely critical will be L5, L4, L6, because we need to know exactly where to space the shear grooves so that they are on the shear plane, which is basically the interface between the different pieces of mating hardware. There are two shear planes, one between L4 and L5, and one between L5 and L6. So imagine if some of these dimensions are critical, mark them critical. If some of them are, say, desired but flexible, mark them that way. If some of them are wide open, mark them that way too. But leaving them blank doesn't necessarily allow us to know if you considered those dimensions or if you just forgot or whatever. So it might be nice to say open or optional or critical, because this is really where we define the package, and this determines, along with the capacity and the desired safety factor, whether the pin is feasible, what material it needs to be made out of, etc. But say you have defined a very high capacity with high safety factor and very small dimensions, for example, that's may not be compatible. So very important page. This page is not optional. Need to fill out at least some of it to get a price. Next slide, please. We also have the loading direction, which is not at all obvious. Sometimes it doesn't matter if the pin can just be placed in any old direction. That's okay. Still need to know what direction that will be. Some customers, though, have very specific requirements. They want the keeper plate, they want the cable clock in a certain way, but then the orientation of the load comes in at some angle. And you're just like any load cell, you have to load the load pin on axis. So the load pin will have an arrow engraved on its end, and that is direction of load. And that has to correspond with the direction the load is applied. So right here is where you could sketch that. Again, if you don't care, it's open. Typically, if not specified, the load direction would be as shown here, or maybe up and down in the page. It would never be at some funny angle, though, if we just were to pick. So if it needs to be something specific, need to specify that. And again, a little sketch here would be appropriate. Moving on. This has to do with what is the maximum operating load. And so that's like, what is the measurement range of interest? And the proof load would be, what do you want it proof loaded to? What load would you like it to survive without damage? And those may or may not be exactly the same thing. Many lifting customers have very specific requirements. They want to use it to this capacity. They want to proof that it's been proof loaded. So that's actually on the certificate showing proof loading to some higher capacity. And then there'll be an ultimate load, which is when it actually breaks and drops the load. In test and measurement, you don't want anything breaking. Parts can be damaged, people can get hurt. But in overhead lifting, it's extremely critical, right? There are safety factors that are designated by law, and they must be adhered to. And a lot of different companies operate in different industries, so they may have different requirements. But in the end, for overhead lifting, there's typically a very strict requirement for safety factor. And so again, that's real important. And then you have, is a pin bidirectional? Inherently, these are strain gauge products. So if you push or pull on it, you get a positive or a negative signal, just like any load cell. Now, sometimes the hardware may not allow compression, say if, the hardware will buckle, but the pin itself can measure in both directions. So does it need to? And if it's millivolts per volt, not so critical. If there's a 4 to 20 milliamp amplifier in the pin, then extremely critical. If it needs to measure in both directions, then an amplifier would be a 12 milliamps plus or minus 8 milliamps. If it's only single direction, then we would just go 4 to 20 on the amplifier over that single direction. In that case, though, the pin is not able to measure in the opposite direction because 4 to 20 does not flip sides. We can also do voltage amplifiers, though, so say plus or minus 10 volts. That'll work too. In those cases, it's always bi-directional. Again, does it get calibrated and proof load in both directions? Not necessarily if it's only going to be used in one direction. So important to know, bi-directional or not. Again, dual bridge or not. A lot of our aerospace customers want 2 bridges, an extra bridge for redundancy. They may compare the 2 signals during operation, and if they deviate from each other, then they know there's a problem. Or if one fails, they have a second as backup. So if so, how many? Probably triple bridges aren't going to be super common. Might be possible, but definitely 1 or 2 bridges. And then the electrical connections. Does a customer want 2 completely redundant systems such that they have, say, 2 connectors and 2 cables? And if one gets broken, the other remains. Or is it okay if both bridges come out in 1 cable, for example? Dual bridge can also be amplified, so it doesn't want to be 4 to 20 or plus or minus 10 volts. Again, you want 1 cable or 2 for that. Dual axis, we can also do dual axis. So the difference between dual bridge and dual axis is a dual bridge are 2 bridges on a single axis. So a single axis pin, say in the X direction only. A dual axis pin would be X and Y. So it'd be 2 axes, 90 degrees to each other. We've also done dual bridge, dual axis load pins. Yes, you guessed it, for our aerospace customers. And so we've got redundancy in each axis. Again, we can do that. Some of that is limited to the size of the pin. So a very small diameter, high capacity pin with dual bridge and dual axis may not be possible. A lot of pins, though, no problem doing that if they're large enough. Again, if you have dual axis, which cable exits, you want 1, 2. If you have dual bridge, dual axis, you could have up to 4 cables. That may be desirable for redundancy or maybe a pain in the neck if you don't want to deal with 4 cables. Your customer doesn't want to deal with it. So important to ask. Again, what would you do with the dual axis pin? We'll get to that a little bit later, I believe. But just like a load cell, you might want to measure, say, 2 axes. that may be interesting, but more typically a load pin, because a load can, say, rotate. And so you have a load axis that may rotate on the pin, say it's in a pulley in the wrap angle of the cable changes, or if it's in an actuator where it articulates and it rolls on and off axis. The second axis can be used to measure as the say orientation of the load rolls around the pin. You can start to get signal on the second axis, which tells you sort of the magnitude. As your one axis decreases, the other axis increases. You can calculate what the applied loads are, or better yet, calibrate it sort of in situ and correlate outputs to different loads at different wrap angles. So, important subject. Is it subjected to reverse loads? A lot of pins, say for lifting, it's just lifting something up. But if it's in a machine, say it's a clevis, the end of a cylinder that's doing some kind of test, it may be subject to very high reverse load. So you need to know that, just like any load cell. Is it fatigue rated? Will there be impacts? Is it doing a test procedure? Part of a test procedure, is it just a constant lifting? That's sort of a detail of the application. If it is subjected to reverse loads or cyclic loads, it's real important to understand what those cycles are. I had a customer one time, he wanted a fatigue rated load cell. I said, well, what's your loading profile look like? He goes, I'm going to use it a lot. I'll use it at least once per day. It's like, okay, don't need a fatigue rated load cell for that, right? So you define what is high cycle. Is it 10 cycles a day? Is it 10 hertz for, 10 years? Need to know that. And then again, what does the load profile look like? If it is reversing, it's fatigue rated, maybe necessary. Well, what's that look like? Is it always in one direction? Is it both directions? Does it go 50%, 0 to 50%? Does it go 0 to 100%? What's the timing look like? Is there any impact? All of those things, just like with any old load cell, we need to spec that out so we can understand and size it appropriately. Again, down the next part is there any side loading, axial, shock loading under unusual loading conditions? That can be somewhat hard to know in many cases, but sometimes it's obvious. They're going to tell you there's going to be pushing, or sometimes they'll say we want to have some axial load on the pin. You say, okay, that's not necessarily good, but we can deal with it. We need to understand and discuss what details are related to that. So again, good question. You may not know these answers, but again, if you do, again, it has to do with the application too. Details on the application can lead us to answers to these questions. Next slide, please. So environment, in temperature range. People often forget to ask, customers forget to mention. We're doing some load pins that are going into a steel mill, for example, in a rolling mill with red hot bar running very close to the pins. We rated those for, I think 300 degrees C. So it is possible to create high temperature pins. Obviously, you don't do that unless the application requires it. So what's the temperature range? Is it cold? Is it hot? Is it freezing? Are they outdoors? Again, storage temperature. That's important just to know. Is it going to be, say, normally at room temperature? Is it normally in the freezing outdoors and it comes out and wants to start being used immediately so it doesn't have any time to warm up? Or it may see, say, temperature cycling during storage, where you could get some moisture ingress if it's not properly rated. Even if it's going to be, say, indoors, you might get some condensation, for example. So again, important things. What is the full temperature spectrum that the load cell may be subject to, and details on that. Again, IP rating. You may or may not know this, but the application starts to drive the answer to this question. Typically, these can very readily be IP67, IP68, no problem. Deep submersion. Big difference between IP68 and submerged in seawater to 4,000 meters. And we do have load pins that we have sold recently for customer doing recovery work on the ocean bottom, and they needed 4,000 meter submersible. So again, that's a different fluid. It's a depth, which is a pressure basically, and there's also a corrosive fluid, and things like cable length become important. So the details of the environment are very critical. And again, type environment: marine, indoor, dust, subsea, etc. And again, submersible always requires more than just, it has to be submersible. Submersible would be, what is it being submerged in? clear water, seawater, sulfuric acid, hydraulic fluid, whatever. How deep will it be submerged and for how long? Sometimes things have to survive for, a 10-minute test. Sometimes they want to survive for 10 years under depth of submersion. So very important to specify all these, and they will be rated such. So if a load cell needs to be submersible to 10 meters for, 10 hours, it'll be rated, maybe tested for that. And then the customer submerges it to 20 meters indefinitely, right? It may fail. They may come back and say, hey, it failed. Why? And the answer is because it was submerged much deeper than they told us. So important. And that will be on the quote. If it's submersible, it'll be specified, not just submersible, but submersible, this fluid, this depth for this duration. And electromagnetic noise, that has a lot to do if we're doing the wireless transmitters, but it's also just important to know this is nothing new. Load cells, these are Wheatstone bridge load cells, so nothing specific about load pins that make them more or less susceptible to this. But if we know it, we can help mitigate it. If we don't know it, the customer will complain about it afterwards potentially. And at that point, it's a little too late, or maybe too late. Vibration, yes or no? Sometimes these will be on machinery. There may be a lot of vibration. Would be interesting to know that. Again, any chemicals or compounds, again, even if it's not submerged, it might be subject to wash down or maybe splashed with hydraulic fluid or acid, or who knows, right? Please ask. Moving on. Material. You may or may not have any idea what material the pin wants to be. That's fine. If you don't, that's fine. Don't fill this part in or don't care. But very often customers do have very specific material requirements. And if so, they'll tell you or ask them if they have a specific material requirement. Wouldn't necessarily ask that because the answer isn't wide open. Certain materials aren't as easily obtained or as easy to work with for load cells. But, if they do have a requirement, great. And we have a number of aerospace customers who have had very specific call outs on the material they wanted. They wanted special stainless. In some cases, we had to actually source a material, or they had to source a material, and then we made the pin out of the material they sourced because the material was so hard to find. Again, some of these aerospace customers have a lot more resources as far as material. They may be already using some special material in other products, and they can source it for us. Again, are there any material certifications required? Things like rupture testing, impact testing, specific strength. There's a whole lot of material certification that is possible. Selling our normal load cells, like low profile load cells here in the US, at least, it doesn't come up very often. Really can't remember anybody asking for material certs, whereas with pins and items used in lifting, marine winching, various applications where it's common, customer always asks for the material certs, and they're required as part of the purchase, and that's okay. We routinely provide it. Also, things like dimensional inspection with the drawing showing the actual dimensions measured. That can be pretty critical on a load cell with threads. As long as the threads are okay, typically it'll fit. On a load pin, there are a lot of dimensions that may be extremely critical, so the customer may want to make sure those have been inspected. We can provide that. We need to know, though, afterwards. So certainly the dimensional inspection cannot be done after the fact. If it wasn't done and then they ask for it, of course they could send the pin back or they could measure it themselves. But if they want it certified as part of the purchase, we need to know that ahead of time. Moving on. Back up a slide again. Sorry. One thing important to note too is salt water. Some of these, say, higher strength stainless with a condition for higher strength, makes them brittle under conditions with exposure to seawater. And so again, it's important to know what will they be exposed to. Sometimes ask, will it be exposed to salt water? Say, no, absolutely not. It's just parked next to the ocean. Say it's a pin used in some helicopter landing gear or something. Well, okay, parked next to the ocean, it may get salt water spray on it, or it's a salty air environment. So again, very important, even though it may not seem to be. We have an application actually with a big dirigible where, no, it's not going to ever touch the ocean, but, it will be parked, on the coast. Well, that's salty air. So again, that limits the material conditions that can be safely used. So important to know. All right, now we can move on. Again, this is the output. We got lots of different outputs. Inherently, these are going to be millivolts per volt. Typically, they'll probably be 1,000 ohm actually instead of 350 ohm. But again, that's up to the design engineer at time of design. So if there's something required specifically, it's important to make a note of it. Otherwise, it is what it is. And we've got amplifiers. Sometimes they are single-ended. So in this case, 0.1 to 10.1, that's a unidirectional amplifier. Great if you're only going in one direction. Sometimes too, people like the 0.1 offset because if 0 volts, that means nothing, right? That means an amp's broken. Whereas 0 volts on the 0 to 10 volt amp, that could just be zero load. Same with 4 to 20. 4 milliamps is, say, the zero condition. If you get 0 milliamps, right, that means there's a problem. So people like that feature sometimes. Again, we can use 0.1 to 5.1. Just depends. One's not better than the other. The customer may have a specific requirement. Two, how much overhead do they want? These amplifiers don't go widely over range. Their data acquisition may not go over range either. So if you say a 0 to 5 volt signal into a 0 to 10 volt input range on the amp, that would seem to give you some overhead on your measurement, except the amplifier is actually going to rail at somewhere in the 5 point something range. So that's important. 4 to 20, again, the 20 milliamps doesn't go up much above 4 to 20. I'm sorry, it doesn't go much above 20 milliamps, and it doesn't go below 4. So if it does, there's a problem. It can be an indication of a problem. If customer wants to measure in both directions, clearly we need to specify it then as a 12 plus or minus 8 instead of 4 to 20. Say another thing to note, we have a number of pins where we have, say, a working range, you have a capacity, you have a proof load, and you have some, safety factor. And some cases, a customer may want, I don't know, 6 milliamps at some specified range, and then they want, 16 milliamps at the capacity load cell, and they want 19 milliamps at some proof load. And so they may specify, something a little different than we're expecting from our test and measurement customers, where it's just 4 to 20 equals 0 to capacity. So many cases with lifting, they may want to see if that pin gets overloaded during a lifting event, they need to know it. And so if the amp rails, they don't know how far it went. If it was too far, they have to pull it out of service. So little details like this are important. Again, afterwards, if you haven't specified it, they get the pin. Oh, by the way, we needed that, right? It has to come back, rescale the amp. The amps sometimes are, inside welded in containers, so it's not so easy to change after the fact. Get lots of digital outputs available. We've got ASCII or RS-45, Modbus, various things can open. We can also do other, basically any other protocol that somebody wanted. We did, to specify it. Or we can do wireless, as mentioned here. So moving on. So these talk about optional features. Again, the customer may or may not have any requirement in these regards, but it's nice to let them know there are options and have them tell you if they care or not. And if so, you can circle what they want here or just point it out. But we've got different orientations of the cable, right? And that's important if there's clearance issues, or say it's a lifting, they don't want the cable, say, poking outside, they want it coming in line with the cable, lifting cable, for example, or all kinds of different variations of what they may want. They have some clearance issues. So we can have cable glands with integral cables. We can have connectors or cable can come out radially or axially. There may be some specific clocking on the electrical that's required. We can have a buried connector, or you call it a recessed end connector, where the connector is, say, embedded in the end of the pin, so provides connector protection. And that could be a connector, or it could be an integral cable with that protection. And then you also, on these pins, right, they need to be kept in place. And so we have something called a keeper plate. Keeper plate accomplishes two things. It keeps the pin from coming back out. So basically you insert the pin into a hole. What keeps it from coming back out? There are various methods. One is a keeper plate, which keeps it in place. You can also have a circlip, which you can see in the bottom left. That's a pin with a circlip and a cotter pin hole. You can have double keeper plates. You can also have a threaded end on the pin and a nut, and that'll keep it in place. And then you also have rotation, right? We talked about there being a specific load axis. In many pin joints, it doesn't matter if the pin spins freely, right? It may be desirable. Certainly it doesn't hurt anything. Well, when your load monitoring pin spins, it loads, the pin spins off of the load axis, and you may get zero output depending on the orientation. Certainly large errors. So it's important to keep it from spinning. So a keeper plate does that as well. It fits into a groove that not only retains the pin but clocks it. The nut doesn't keep it from spinning typically. It's important to note too, if there's a threaded end on the end of the pin, that's great. It's important to know that that nut not tighten the joint and act as a bolt. It's a retaining feature, not a clamping feature. And so imagine if you have a set of fixtures where you're loading your pin and it's loading hardware. If you were to clamp that joint tight with a nut on the end of the pin, eventually the joint isn't free to move and you get no measurement. You start to get parasitic loads, errors as it gets tighter. Eventually it locks up and you get no output at all. Or you may get some output and it slips and then it sticks at that output. So bad news, shouldn't apply an axial compressive force to a load pin ever. Greaseways. Sometimes these have sheaves, bearings, things on the pin. Do they need to be greased? If so, no problem. Zerk fitting, a grease fitting on the end or the edge of the pin, and then a grease pathway that can channel the grease right where it needs to be. There could be dual greaseways, very common. Of course, you need the real estate, so certain pin dimensions don't really have any room for greaseways, but plenty of them do, and it's super common for certainly in marine applications. All right, moving on. Again, this talks about the cable exit, again, cable gland, connector, radial, axial, what end of the pin. You can guess on this if it's not specified. Please specify it though, or say don't care, because it may change pricing, may change the design. We'll eventually after purchase, do an approval drawing, and at that point the customer can also mark it up. But it's better to get it right the first time so we have fewer iterations of that. Moving on. This talks about, again, clocking. We have a clocking of the load direction. This is a clocking of the cable exit. Again, in pins, it can be quite important. Depending on what the other hardware looks like, there may be limited room for the cable exit, and the customer has a very specific requirement of which way they want it oriented. No problem. Need to specify it, though. Another thing I think I forgot, or maybe we'll get to, but I'll mention it now, too, is these cable exits are designed as a system. So you got specific cable glands, you have specific cable jackets, cable diameters, cable materials, number of wires in the cable. All of those include the system. And so when we do submersible or high IP rated sensors, it's not just mix and match. And so there are certain combinations that have been approved, maybe have been certified, have been tested, especially for hazardous environments. There are very specific combinations that have been tested and approved. So it's not just mix and match. So I want an integral cable, but I want, 7 wires. I want, these specific colors. That may be okay, but may have trouble then meeting the environmental ratings if it's kind of a new combination that hasn't been tested. So just keep that in mind. At Interface, we've kind of just been like, oh yeah, whatever you want on the cabling, but they're not necessarily designed as a system to be environmentally sealed, whereas these are. Next slide. Okay, mechanical protection of the cable necessary, and there's lots of ways to do that. It can be, say, a recessed connector. It can be plates or some kind of brackets or something that protects it. It can be a beefier cable. So again, is that important? Sometimes it's real important. We do hose protection, where you actually have a hose that protects the cable, and the hose fitting, say, screws on to the electrical connection at the load cell, for example. That can, or maybe it clamps on. That can be real common if there's like, caustic fluid or something. Also, if you're like running these things over with cars or something, machinery, it can make the cable more durable. It's an option. Need to know specifically what the customer is trying to protect against, and what the details of that might be, but certainly something we can do. Again, is there a specific cable type? Fine, we need to know. Otherwise, it would be one of our standard cables. And again, does the customer want specific core colors? We have standard core colors. If they have specific, we need to know. You need to know it beforehand, and sometimes it requires buying a whole spool of cable, and we need special cable if it's going to be rated for depth or submersion or IP rated. It may be that it has to have a specific type of jacket and jacket dimensions and thickness and all that stuff. So we need to know that, have to specify it, may have to go out and buy a big spool of cable. May actually have to do some testing on it depending on what the actual requirement is. So again, important to know if there's something non-standard required. Moving on. Anti-rotation. We talked about this a little bit earlier, but typically the pins always include a keeper plate and a groove for the keeper plate. The keeper plate is a separate item. So if you get a load pin, the keeper plate is a single keeper plate that's loose. It doesn't come with any screws, but it has holes in it. And the idea is the customer inserts the pin, and then you slide the keeper into place, and then you put your screws through the keeper plate into part of the customer's assembly that holds the keeper plate in place, that therefore then keeps the pin in place and keeps it from rotating. There are other ways to do things other than keeper plates, and you can see here you could actually have 4 positions. Some customers want all 4. Typically that's redundant, not necessary, but they may want 2. They may want 1, but they want it in a specific place. Again, some hardware may not have any room for a keeper plate, or it may only have room for, say, at one end or the other. Again, if they do not specify, the keeper plate will just be of reasonable proportions. They look pretty much like they are drawn here. Customer may want a rectangular, or sorry, they may not want a rectangular keeper plate. They may want a, say, triangular shaped keeper plate. They may want some different shape. That's fine. They may want it welded to the load pin. That's okay too. Increased costs, but certainly things like that are possible. Sometimes customers have a specific size hole they want in a keeper plate. Funny, that doesn't come up nearly as often as I might have anticipated, but in any case, if they do, great. What is it, right? They may want 3 holes instead of 2, right? They may only want 1 hole. They may need a special shape or something. We can do it, just need to know. Moving on. So this is a grab bracket. This would be commonly used on a load shackle, where that bracket, say, grabs one of the arms of the shackle. You can also have like a hydraulic cylinder or something where this pin goes at the back of the cylinder. One thing to note is the pin wants to be clocked, as in it has a load axis, and you want to clock that load axis to something. If you have an articulating joint, the question may be, which side of the joint do you clock the pin to? And sometimes it's obvious, if one side is fixed, and then say in a hydraulic cylinder, you want the pin load axis to always be in line with the cylinder. So you'd have to clock the pin to the cylinder, not to the bracket that the cylinder is attached to. So say you have a clevis on the end of the cylinder, and then that clevis engages a blade on a fixture. If you clock the pin to the blade side, or the dead side, or the ground side, you might call it, now as that actuator kind of rotates or articulates on its clevis, you're going to rotate off axis on the pin. But if you make the pin follow the hydraulic cylinder or the actuator, then the load axis stays on axis. So how would you do that? Maybe a lot easier to clock it to the fixed side, the ground side, but that won't work. So maybe you need a grab bracket. This would be that. And there's lots of examples of what a grab bracket could look like. Sometimes the customer can tell you exactly what they want, or they just say, here's what the hardware looks like. Please suggest something. I'm giving an area here for a sketch. Again, you can sketch here, have the customer include drawings, right? Drawings are great. Photographs, drawings, everything they can provide. As Jeff pointed out earlier, though, that's not necessarily enough. Oh, here's a photograph. I want this pin. We want more details. A lot of times a dimensional drawing of a pin that the customer has is really a pin that wasn't load measuring, right? So it lacks some of the critical details that would be required to turn it into a load pin. But pictures and drawings help. Another thing when we're on that topic, I've had a number of customers who, as Jeff mentioned again, they don't think you need to know, or maybe it's military aerospace. So, need to know. You don't need to know, so they don't tell you. Well, then it doesn't work. And I've had this happen a number of times now where these, big aerospace customers or customers who are dealing with big aerospace companies have been very reluctant to provide details. And then when it doesn't work, now they end up giving all the details anyway. And then you're, oh, that's why it doesn't work. If only we'd known that ahead of time, right? And so I use that as an example when I talk to customers. You may not think it's relevant, but if they're just sending you like a little snip of a drawing or you can't see anything around it and they won't tell you what they're doing with it, okay, but it's on them if it doesn't work, right? And depending on how the hardware interacts with the pin, it may not work. When I say it doesn't work, it may not work at all, or it may just give them larger errors than they want, right? And at that point, it may be too late to fix the problem without redesigning hardware if you find it doesn't work well in the application after everything's already manufactured. So more information is better. Moving on. Again, this is an anti-rotation block. So not to beat a dead horse, but there are lots of ways to do anti-rotation. This would be if somebody wants something other than a keeper plate, specify it, and they may or may not know what they want. Sometimes the hardware dictates it and says, "Oh, there's no way a keeper plate's going to work here. It's going to have to be something different." So if you know what it is, customer knows what it is, here's where you would specify that. Moving on. This talks about a threaded end potentially, or a circlip, or a washer with a cotter pin hole or something, right? So again, lots of ways. This would be not necessarily for anti-rotation, but this would be retaining the pin in the joint. If you have, say, 3 pieces that are held together with the pin, and that's your loading hardware, clearly you need those pieces to all stay in place. And so the pin has a head on one end, which could be the retaining, on the one side, and then the other side could have a threaded hole with a nut, could be a washer, could be a circlip, could be a cotter pin, could be any combination of those things. Again, if the customer has specific requirement, or they could draw up what this hardware looks like, and we can help understand what the retaining feature needs to look like. Here's where we would provide those details. Moving on. Greaseways. We actually quoted load pins to a customer in crane application, crane manufacturer, and they came back, "Oh, my management said there's no way we could use load pins because they have to have grease, and load pins can't have greaseways." So, sure they can. Oh, okay. So we added the greaseways, but if they don't ask for them, they don't get greaseways, because a lot of customers don't want or need greaseways. But they may have a specific nipple they want to. We call them Zerk fittings here in the US. I'm not sure in Europe, but certainly there are other types of fittings that could be possible for grease. And then, of course, not only where the grease fitting wants to be, but where do the holes for the grease exit from the greaseway want to be. It might be in the center, might be on each edge, might be center and each edge. I've also done some kind of crazy spiral cuts in the exterior of the pin so they can be greased externally, and the grease can make its way into the hardware. I think that's less than desirable, but again, if the application requires it, it can be done. So just need to know, is greasing important? Greaseways or some method of grease introduction required? If so, we can do it. Moving on. Testing and calibration. In calibration units, typically these are going to be in, say, tons, metric tons, could be in pounds, could be in newtons, could be in kilograms, right? We need to know. Sometimes it's real important, in the cal cert, it says applied load and output. So typically some customers, if it's, say, done in pounds, particularly over in Europe, and now they want it in newtons because they don't like pounds, and you can do a conversion. Now it's kind of non-uniform Newton numbers, and people may or may not like that. Or again, if it's wireless, that's hard baked into the wireless amplifier during calibration, so it's not as easy to change. Maybe stuck in the calibrated units without some kind of a complicated process to rescale it. So important to know. And why not know it ahead of time instead of the customer going, oh yeah, I wanted it in kilonewtons and you did it in metric tons. Okay, we could have if we had known. Again, is there a non-repeatability or non-linearity requirement? I don't really leave this wide open. The customer says, yeah, 0.1% or as good as you can get. Okay, as good as you can get, that's easy because that's could be anything. But what do they really need? What do they want? What are they trying to do? They're trying to weigh something accurately for sale? Okay, that's a big deal. Maybe they do really need high accuracy. Is it safety related? Well, probably it's not as important as they may think it is, plus or minus a Newton on a, 5,000 Newton lift, probably not a big deal. So what are they trying to achieve? Sometimes they don't know the answer to the linearity and specification, but sometimes they do have a very specific requirement. So need to note it. Remember pins too, they are typically going to be in the 1%-ish range. The standard load pin data sheet, I think, maybe lists 0.5% to 1%, something like that. But in the end, it really depends on the design. If you have a very high capacity and a very small diameter, very short, sort of max out any given dimensions for capacity. So make the specific dimensions and make it as high a capacity as possible. That's not going to optimize the performance, right? And also the mating hardware and the interaction between the pin and the assembly it's mounted into makes a big difference. So again, the pin could be quite accurate and very repeatable. If the hardware is sloppy or bends, it may end up being quite non-repeatable. So just important to know customer has specific requirement. We need to know what it is. And sometimes it's not a percent. It's, oh, I want to be within X number of newtons, or I want to do this. So just need to know. And the standard product has standard specifications on it, so those can be used for reference. Again, is third-party witnessing of the calibration required? Yes or no? We don't want to encourage this for things that don't need proof loading or, say, safety related. Sometimes it's very common for that. In test and measurement, we don't get often asked for witnessing the calibration. It's kind of a pain, so you want to charge extra for it because customers kind of come in. Generally, you have to set up sort of a special show and tell for them. So it's quite disruptive to the factory. So it's definitely something you don't want to. Oh, by the way, the customer's going to come in and witness it. But if they want to, it can be done. Need to be specified, and it's not super unusual in lifting or safety related things. Again, there may be some classification society they're witnessing it for. Which one, right? You know what to expect. Then if there are any other safety requirements or testing requirements, need to know. Pressure testing, crack detection, insulation testing. We're doing calibration for a customer here in town who does lifting. They use dynamometers, which are like shackles with displays attached to them, and they have a very specific requirement when you calibrate. You also have to proof load. You have to load the proof load for X number of minutes. You have to observe the system for elongation or evidence of cracking or deformation. And so normally we get a load cell in for calibration. You exercise it, you calibrate it, you document the calibration. You don't document that it's been exercised. You don't have any specific loads that it went to during exercise, and you're done. Whereas these, you need to know this. You need to measure the length before and after and during. You need to, visibly observe it. You need to do this and that. So again, we knew it, just need to know. Moving on. Again, certifications, machinery directive approval, yes or no. It's hazardous. We definitely do lots of hazardous rated product. LCM is very good at it. Have a lot of product interfaces good at it as well. But we need to know specifics. And we're not the experts. There are experts. Interface has an expert. LCM has an expert or two. That's actually a thing. Companies that sell hazardous rated product have to have, designated experts. We let them talk amongst each other when we're specifying these things. So we say, here's what we're providing. Let the customer decide with their expert whether it's appropriate. If not, they'll tell us specifically what they want. Our experts review and propose. But in the middle, you want to be careful as a middleman. You're not offering advice. You're not telling them how to make sure their systems are, not going to explode, right? That's not for us to say. And they need experts on their ends. So just bear that in mind. It doesn't have to be CE marked. If so, great. If not, we won't. Some cases we will, and some products may always be CE marked, for example, but it's good to know if it's definitely required. Need to know that ahead of time to make sure it has it. You get any other certifications? Good to know. Again, at the quoting time, not the receiving the order and realizing it's not there time. So moving on. I think we must be coming towards the end of this configurator. So if possible, please include photographs, anything they can. If it's replacing a non-instrumented pin, we want a drawing of that original pin. Can take a caliper and measure the hardware if the customer doesn't know. Machinery, they may not have never cared what these dimensions are. They may not have a drawing, but they've got a caliper, they've got a tape measure, they've got a ruler. For quoting purposes, it's not extremely critical to get the dimensions down to the fractions of a millimeter. But when it's manufactured, yes. So the approval drawing will have very, explicit dimensions on it with tolerances. Again, those may make the difference between it fitting or not. So the customer has final responsibility. Will this fit? Signing off on the drawing means they have approved that it will fit. But please, anything they can provide to help us make sure they get the right product in the first place is very important. Again, more information is better. Some guys, they don't want you to know. Well, they'll wish they'd told you when it doesn't work. Next slide. And finally, just different cable exits and configurations. I think this may be redundant, actually. So skip this one. This talks about how the load is applied. The assumption is it's applied uniformly across the entire active section. Some cases, the customer may have a bearing or something with bushings. They may not actually be applying the load, right in the center, or it may not cover the entire section. Need to know that. Moving on.